Ranjan Kar and
Akhil.
Akhil,
Akhil Gupta.
Akhil Gupta. Manas Ranjan Kar is currently leading the text analytic practice at Juxt,
Smart mandate.
Juxt Smart Mandate, a data science company. He likes helping clients making sense of their data and building powerful case for business changes using analytics in their experienced companies. He has architecture multiple commercial NLP solutions in the area of healthcare, food and beverage, finance and retail. He is deeply involved in functionally architecting large-scale business process automation and deep insights for structured and unstructured data using natural language processing and machine learning. Akhil is a final year student in SRM and he's interning at Amazon.
Good morning, everyone. Let me briefly introduce again. I handle the text analytics practice at JustSmart Mandate. And Akhil here is a final year student at SRM University, Chennai. And he is also interning at Amazon India. And as you will see in these slides going ahead, that we also use Amazon reviews. So his background also helped quite a lot in the entire setup. So I'll start off with what is the goal of this entire presentation. Now, of course, as the title said, is that we want to showcase a framework by which we can use unstructured data, that is the text reviews itself, and can we create a recommendation system out of it, and which are more contextual and which are more powerful in nature. But also there is a secret goal that I have when I come up and speak in front of you. That secret goal is, of course, to showcase that some of the experiments and the business hypotheses that we generate can, of course, lead to good business outcomes. And me and, of course, my company, Hereford, are a big believer in open source and contributing to the open source community. And yes, and to take feedback from you, and please keep me honest. So I'll start off with some famous outcomes. This is something that anyone who started off with working with word embeddings on NLP has been seeing on a day-to-day basis, is that a relationship between king and queen is same between a relationship between a man and a woman. And you could actually generate equations like, say, man minus woman is equal to king minus queen, and so on and so forth. And so how does this exactly work? Now, once you have a multiple set of text, you essentially take it, and each text or each token essentially represents a vector space coordinate, or context vectors as we call it. And that is what is showcased in a multi-dimensional space. And the closeness between them in multiple cases is the cosine similarity, is what defines how closely semantically similar they are. One of the misconceptions that most of the people, when they start off with word2vec, is that they believe it's deep learning. It's actually not. It's actually shallow word embedding model. And the whole idea of word2vec is very simple. A word is known by the company it keeps. The closer a word is to another word, they are thought to be semantically similar. Now, you can generate such similarities across domains, across business use cases, and whatnot, and which I'll showcase some multiple use cases that I've used this exact framework while I'm at work. So the idea of entirely word-to-vec representation and or any word embedding based representations is, can we generate better word representations, and by reducing the model's complexities. So to showcase what word2vec exactly does quickly is that once you run a pass through your entire text piece, and you have generate IDs, and you assign IDs to each of these tokens. And then you start mapping them into a vector space using the algorithm that word2vec essentially uses. And the training is again online, and one example at a time is what it takes. There are two architectures. One is a skipgram and one is a continuous bag of words. Now, a skipgram basically predicts the context given the word, and the continuous bag of word predicts the target word given the context. Now, a simple thumb rough rule essentially says that skipgram, please use skipgram when you have more data, use continuous bag of words when you have less data. But however, confusing and contrasting views do exist, which entirely depends upon your experiments and your use cases. To tell you why skipgram essentially works larger with larger data sets is that each token and context pair is treated as a unique pair, and that largely works in larger data sets. However, if you have smaller data sets, it can help increase the accuracy for rarer words. And continuous bag of words, on the other hand, will give you better accuracy for most frequent words. Now, why recommendation systems? I found that this is something which is very relevant since Andreas is here as well. That recommendation systems are broken. They do work most of the times, but they are broken some of the times. Here, Andreas is talking about that when his book comes up in Amazon, essentially Amazon suggests Excel. And any guy who works with machine learning and he's a deep worker in machine learning will scream sacrilege. And that's what it was. So taking this forward, this idea forward is what do we essentially want to do? We essentially want to propose a framework, and we'll showcase how we have done it, to artificially introduce context into your entire word reviews. And how to generate recommendations, of course, out of it. So the data set in question is Amazon's data set, which is a review data set of more than 18 years. So the one that we took is from Jay Macaulay. Your laptop is okay? I don't know. Projector is not working. It's again a blue screen. No worries. Please bear with me. Murphy's Law at work.
Just keep it connected. There's an internal error from that.
Yeah, I know. Yeah, where's Jimmy converters? Projector not working. Yep. So there must be some problem. You can go to, is the internet working here? No, try connecting. First connecting to you can connect to this one, not a bit of problem. Already have the slides up. That's okay. It's back. Yeah. It's working. It's a Python 2016. है ठीक है. Do you have internet in yours? Issue can. नहीं मेरे ऑफ ठीक है लैपटॉप दे दो. PPT. Yeah. अरे था खुला था. ड्रैग करो ना ऊपर. Just drag it. Drag it right. Right में. टैब को ड्रैग करो. ठीक है. नहीं ठीक है भैया तो ठीक है जाओ 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 ठीक है. नहीं लोड हो रहा ना. Quite a long delay. Yeah. So Murphy laws again. Sorry again. So as let me then go back to where I was. So we use Amazon's reviews. In this case, we only use digital music reviews, which were 800K plus, and we also use the user browsing history, which were 9.4 million records. Essentially, what we are trying to do is create two models. One is the meta model, which is based on the user browser history, trying to mimic the typical recommendation systems that you will always find, which is a product recommendation system, and a user review model. So this is something that we're trying out on our own situation is, can we predict certain contextual recommendations from these reviews itself? Now currently most of the sites that you go to, food reviews or the travel sites, don't allow you to search on context. So for example, if you search say best chicken tikka or best biryani around me, you may get only those restaurants which have biryani in their description or their title itself. Now what we had essentially was these two data sets. The first data set was user reviews, where we had the product ID, which is as in, and the review text itself. The second data set that we had was the user metadata, which is its interactions with Amazon itself, what he bought and what he viewed together, what he bought together, and so on. From there, we essentially use the product ID, the price, also bought, also viewed, and the bought together product IDs. So the metadata had only product IDs itself. And these are the pieces that we essentially ended up using. Again, this data set comes from Jim Macaulay's website. So we had data something like this. So after extraction, so our data set looks something like this. So the user reviews and the metadata itself, and which composed of multiple product IDs. What we essentially did was we transformed them. For user reviews, we essentially ended up transforming by prepending and appending the price information and the product ID information. Because essentially we are trying to build context. So why not artificially introduce context from the price and the product ID itself? So for prices, we created multiple ranges, less than $5, $5 to $10, and so on. And also introduced the product ID before and after the review itself. And we lowercased, and the other major transformation that we did is that we converted key phrases and the entities into single tokens. Say something like Shankar Mahadevan becomes Shankar underscore Mahadevan. Something like say wonderful time becomes wonderful underscore time. For this, we essentially used parsers from NLTK. We created our own grammars. And we did not use DBpedia because, again, that's very heavy and somewhat buggy. For the metadata itself, we took the product ID and we prepended, for bought together, we prepended B underscore T. For also bought, we prepended A underscore B. And for also viewed, we prepended A underscore V. Now, the reason we placed bought together closer to the product ID is we wanted to increase its weight while training, and to showcase that these are the more important product IDs. This is how our entire pipeline currently looks like. Now, again, this is such a framework, and it does have some scope for improvement. So we have a model creation phase where we are extracting the user browser behavior, and we are doing the normalization and stuff. We are doing the key phrase and the proper noun tagging. And after that, we are creating separate models. So we created roughly 6 models, which we are going to release after the talk. And we're also loading the product metadata into the Redis database. So as when we extract product ID information, we are able to locate it in a database and find its relevant metadata. But we did not use it into our training. Interestingly, what we found is we were able to categorize each of those products according to genre. Now, when we searched, this is something like say rock, we used to get albums which are related to rock itself. However, we did not take rock metadata information into the training itself. We only got that this product is a rock related product from its reviews. And that is what was also interesting. And so what we wanted to do is create these kind of test cases, is that given a keyword, can I create a query which says give me this and give me only for a price less than X. Another would be a plain and simple query of that same keyword itself. And again, give me jazz plus instrumental, say more finer points of a certain category. And these were the 3 kinds of queries that we ended up creating, and we'll be showcasing them as well. Now, this talks about the previous slides talk about what we essentially did in our experiments. And so we have been using this in our own firm and in my own practice for our multiple clients. And these are certain use cases that we have been using similar techniques and frameworks for our company. So one is, of course, product title rewriting for SEO clients. So now a client has multiple e-commerce websites, and he needs to rewrite certain articles because a person lands to that website writing, say, long-sleeved white T-shirt, but the product description of the product title itself may only say men's T-shirt. Now, how do I add those additional pieces of information and keeping the real metadata of the product itself in context? And of course, this is something related to machine learning. As you would work with textual data, you normally end up with tons of features. So to compact features and to make your features even more richer, can you combine those features together? Now, for example, can bank and financial institution come together? Can bank and Citibank come together as a single feature? And the counts be counted as one. And also, we are using it to validate and refine ontologies for multiple niche domains. For example, healthcare reviews and voice of patients. and SKU reorganization and genre validation, as I just spoke about. And of course, sentiment analysis. Now, this is an interesting use cases that you can't use sentiment analysis with word2vec out of the box. What you essentially need to do is you need to club it together with something like, say, a wordnet or a senti-wordnet to understand the polarity between multiple words. Now, it will tell you that good and bad are related and they're close by, but whether or not they have a opposite polarity is what something like a senti-wordnet will tell you. And very close to this current use case that we have created, we also building a recommendation engine for Indian restaurants, which says best chicken tikka with a certain seed restaurant, and you can get recommendations for multiple restaurants, such restaurants. Now, so I'll hand over to Akhil for a quick demo of how it essentially looks and works like.
So basically our model, it supports 3 types of parameters. One is text, one is async, and another is async plus price. So in text itself, we have like, which supports multiple categories. Like you can even search for artist, you can search for musical instrument, and you can search with the band name itself. So it can give recommendation on basis of all these, whatever the inputs you give, and it supports all these 3. So I just show you like all those combination. For example, jazz is one music category. So okay, so yeah, these are the recommendations for jazz music, and yeah, these things which is numbers. Basically, these are the essence of Amazon. ASIN is simply a Amazon standard identification number. It's a unique number by which you can fetch the data for specific products. So yeah, I'm just using this to compare my results with the Amazon results, so that we can define some accuracy of our model. So right now we tested our model on multiple inputs, which I already told. So right now we are getting 58% accuracy for the top 3 results which we are getting right now, and yeah. So
Price.
yeah.
Price.
Okay. Yeah. So I'm going to show you one more input. Let's say jazz, price, which is less than $1. Yeah. So all these recommendations are for music jazz, which has a price less than $1, and still the accuracy remains same, like 58%. It varies from 50 to 60%, but on average it is 58%. And
so essentially what we did is that we had tagged the price information as well when we were analyzing the reviews. And using that, we were able to create a query which says, give me a album or give me a digital music a copy of the less than this price. And that is what a word2vec or a contextual artificial introducing context can do.
So this is demo part, and yeah, I believe that yeah, and however I work in Amazon, so I don't say that this like basically our recommendation is basically on product to product, but what other recommendation systems are there? They track user interaction with the website and tries to find out the pattern, and on the basis of that they recommend products. So but still our model, it provides a starting point to start a new trend and give a good recommendation on the basis of contextual word embeddings. Yeah, so still our model has a scope to do better. So first of all, right now we are using an NP parser for tagging the entities, but instead of that we can use dbpedia datasets, which is more rich in terms of entities, and yeah, we can use that to tag entities. Second thing we can do is we can experiment with the parameters. Like it depends on the data set which you have. For example, you can experiment with the dimension parameter. You can use skipgram or continuous bag of words. So as Manas already told, what is the thumb rule for skipgram and continuous bag of words. So yeah, these 2 are the most dominant parameters in terms of creating word embeddings. And second thing, in our model, we are separate. Right now, our meta model and review model, these 2 are separate. But when you combine all these models and again train a model on the basis of your parameters and your data set, there may be a chance that you can get a more accuracy as compared to what we are getting right now. And yeah, so other thing is what we can do is right now we are manually testing our system accuracy with the other systems, but you can automate this process by using certain tools. Yeah, so I again hand over to Manas.
Thank you. What we are essentially doing is we are outsourcing, open sourcing the codes and the models that we had created for this experiment at this place. So it is in my GitHub repository. And please feel free to touch base with me or Akhil in case you are not able to get it working or you want more information about what we did. So we are also releasing the 6 models that we had created for digital music using multiple hyperparameters. For the data set itself, you could go to Jay Macaulay's website, and we have also mentioned that in our repo. However, to get the full data set, you would have to drop him an email and take his permission to use that data. However, you would get access to some sample data set, which is roughly 10% of your entire review set, and start working with it.
Yeah. Hi. So my question is regarding named objects. So say suppose in a review you have contextual data about somebody recommending another restaurant or another book. How would you differentiate between the name of a person there, say the author, and the name of the book? So how would you create a structure out of those two?
Can you give me an example as what may be that review or text?
Something it might be, I didn't feel this restaurant to be good. The chicken tikka was not so great, but I had chicken tikka, say, at XYZ restaurant.
Yeah.
So now you have the restaurant name and the product name, chicken tikka.
Yeah.
So how would you, when you are structuring that data, how would you differentiate that this is the product name and this is the restaurant name?
Okay, so a couple of points that I can put forth from there is the first part is what we are essentially talking about is relationships.
Yeah.
Now, essentially, whenever I'm feeding any text into Word2Vec as it is, currently we may do some amount of pre-processing, and currently we may do some amount of, say, tagging in terms of product ID or the price ID itself. However, we are not taking relationships into place. Word2Vec, if I feed everything into place, it will, just because it is nearby, it will showcase that the strength of that is such. However, given a larger data set, these associations will start getting more averaged out, and you'll get more truer picture. What you're talking about is can be done using something called a relationship extraction, where I say, okay, the association between this restaurant and a positive aspect, when you do aspect level sentiment analysis, is positive. However, the seed data set, this restaurant itself, doesn't have a good review. Word2Vec, again, it is being used in very analogy oriented use cases. What we have essentially tried to do is take those concepts and try to see if it works in recommendation systems. However, it is my belief, and it is my experience at least, is Word2Vec won't necessarily reach production level in all the use cases. You would need to combine it with multiple other techniques. Say you take the Word2Vec vectors and train a classifier atop it to create, say, document classification exercises or say sentiment classification exercises, or club it together with, say, SentiWordNet for sentiment classification, and so on. So Word2Vec in some of the use cases needs to be augmented with additional techniques, and that is where the value will come in.
I would like to add one more point. The question you asked lies under the domain of co-reference resolution. So there are multiple algorithms by which you can actually resolve the, whatever you're saying. So before training the model, before feeding the model to the Word2Vec, you can actually resolve the your reviews or whatever it is, and tag those resolution with the model itself, like while fitting it to the word to vec. So by using this, you can actually try to improve your accuracy.
Hi, a question from you.
Hey, hi guys.
Hi.
Great talk.
Thank you.
And so my question is, number one, are you using a word-to-vec implementation by somebody else? Like, you
Yeah.
know?
So we are using Jensim's implementation of word2vec,
Okay.
and we are also using some amount of additional pre-processing techniques using NLTK
Okay.
for pre-processing, I think.
Okay.
But we have also mentioned that in our
Yeah,
repo.
I think I kind of haven't seen the repo yet.
Yeah.
So my main question is that at scale, like as of now, if I dig into the repo, is there some kind of map reduce happening so that I could, or it's just sequential as of now?
It's sequential as of now.
Okay.
So it took us roughly 18 hours to train one model.
Okay. Okay.
I'll give you a context of what we did. So a subset of this functionality that we created was created at LTRC IIIT Hyderabad. So me and Akhil met there as a part of a NLP advanced summer school, and we did a subset of this as a project, and once we came out of it, we just implemented a few more pieces. But the core concept remains the same.
Any more questions?
Hello, I have a doubt. Here.
Hi.
Hi. So you said you are performing NLP for what the user is reviewing and all those things, right? Like, if I am telling good, the restaurant is good. It could mean different to different people, right? For example.
So are you talking about this one, this transformation?
Yeah.
Yeah.
It's a general question actually.
Yeah.
So if I'm giving 3.5 for a food or something, a review, and after like one or 2 days, I can even give a 4 or 3. So
Sure.
you can't like tell it's perfect 3.5 and you can't perform analytics over it for it, right? For example, you see a mobile in Amazon. So I'm giving you a set of 5 samples and ask you to rate the mobiles on Amazon.
Yeah.
So you are giving a rating today, and mostly I read a paper that it won't be the same. So instead you can use comparisons. For example, in your case you can ask the user whether he likes chicken or something else, and you can do, right?
So currently in this framework we are not doing any kind of rating as such. What we are essentially doing, so I'll give you a snippet of what we are essentially doing is, so we have a 2-layered recommendation system actually working. So word2vec is one of those layers. So this is not related to this, but something that I'm currently working on. And word2vec gives me the first level of recommendation. And even if a person rates a product as 3.5 or something as that, currently I'm not taking that into my context. However, tomorrow, and since the word2vec algorithm is online, I can start training as if I do get additional reviews, I can train it again in an online manner, of course. And after a certain point of time, I'll see that my ratings are starting to improve. But in this current framework, we are not attempting to do any kind of rating or word sense disambiguation, as you said, in any sense.
Hi. Have you compared this with methods like collaborative filtering or anything like that? Have you compared the accuracy of this with that?
Not exactly. So to get to a closer methodology, what we have essentially done is we have compared this with the actual results of Amazon for that product in the domain of also viewed and also bought and bought together. And that is what we have done. We haven't gone and built a collaborative filtering to compare it to that, because we don't have access to that data. We only have access to product reviews, and we only have access to the also bought together. We don't have access to the rating that a person has given to multiple, basically longitudinal data of a person's user history.
Any more questions? All right then. Thank you, Manas.
Thank
Thanks.
you.
Thank you for your time. If any of you have any feedback to share, please visit